The average temperature of the surface of the entire global ocean hit 21 degrees Celsius in a single day. And the strange part isn't just that it happened, it's why. Because the same weather system baking the United States on the news right now isn't just sitting on top of the ocean, it's helping cook it from above. In a feedback loop, most people watching the heat wave on land have never heard of. Start with the number itself because it's bigger than one. Hot day. Scientists at the Copernicus Marine Service confirmed that June 2026 was the warmest June ever recorded for global sea surface temperature, averaging right around 21 degrees Celsius, roughly 69.8 degrees Fahrenheit. That beat the previous records set in June 2023 and June 2024, and it capped off the second warmest first half of any year on record for the planet's oceans. But the average hides how widespread this actually is. By the end of June, roughly 82% of the global ocean was sitting inside marine heatwave conditions of some intensity. 82%. That is the second largest share of the ocean ever observed this warm at once, behind only 2024. The hotspots were not scattered randomly. They clustered in the Mediterranean, where 98% of the entire basin was affected, the central North Atlantic, and the tropical Pacific. A marine heat wave is exactly what it sounds like on land, just underwater. Scientists define it as a period where the sea surface temperature at a given location sits above a threshold, usually the 90th or 95th percentile, for that spot and that time of year, and stays there for at least 5 straight days. Some of the events active right now have been running far longer than 5 days. Off northern Japan, one marine heat wave has been continuously active since December of 2025. Now, here is the part almost nobody covering the heat wave on land is talking about, and it's the reason this story exists. The heat dome parked over the United States and the marine heat wave sitting underneath large stretches of the Pacific are not two separate weather stories. They feed each other. This is where it gets dangerous. Here's the mechanism. A heat dome is a ridge of high pressure, and underneath a ridge like that, the air sinks and the winds at the surface go slack. That matters more than it sounds like it should, because the ocean sheds its heat back into the atmosphere mainly through 2 processes, evaporation and direct heat transfer off the surface, both of which scale with wind speed. Weak wind means weak evaporative cooling. When researchers went back and reconstructed the extreme North Atlantic marine heat wave of 2023, they found exactly this signature. Reduced wind speeds over the warm water meant the ocean lost less heat through evaporation and direct transfer than it normally would, which let the surface keep heating instead of venting that energy away. So a heat dome doesn't just make the air hot. By calming the wind, it puts a lid on the ocean's ability to cool itself, and the ocean underneath it keeps absorbing solar energy with a weaker escape valve than usual. That is the first half of the loop. Heat dome traps heat. Ocean can't vent it. Ocean gets hotter. The second half of the loop runs the other direction. And this is where the evaporation really matters. A hotter ocean surface evaporates more water into the air above it. Full stop. That added water vapor is not a side effect. It is fuel. Water vapor carries enormous amounts of latent heat, energy that gets released the moment that vapor condenses back into rain, and it is one of the primary ingredients that lets storms intensify and lets already hot, already humid air feel even more oppressive at the surface. Put the two halves together, and you get a loop that reinforces itself. The heat dome weakens the wind. The weak wind lets the ocean hold on to more heat. The hotter ocean evaporates more water into the air. That extra moisture adds energy to the same atmosphere that's already trapped under the dome. And near the coast, here's the kicker. It adds measurable fuel for the kind of extreme rainfall and storm intensity that shows up later in the season, often somewhere else entirely. Both halves of this loop have been measured directly by satellites and instruments. This is not speculation. This is what the data shows. Nowhere is this playing out more visibly right now than off the west coast of the United States. NOAA Fisheries has been tracking a marine heat wave in the Northeast Pacific, off California, that has now persisted long enough and grown large enough to rival the Blob, the infamous 2014-2016 event that reshaped how scientists think about ocean heat entirely. Last September, this current heat wave pushed the average temperature of the Northeast Pacific to 20.6 degrees Celsius, about 69 degrees Fahrenheit, the highest average ever recorded for that stretch of ocean. Water temperatures along the coast are still running 3 to 4 degrees Fahrenheit above normal. NOAA scientists have been direct about how unusual this is. This marks only the 3rd time on record that this largest section of the coastal Pacific has stayed this warm for this long without an El Niño event to explain it. And now an El Niño is arriving anyway, layering on top of an ocean that was already running hot on its own. To understand why that combination should worry anyone downwind of the Pacific, you have to understand what happened the last time a heat wave this size sat in the same place. The blob was not an abstract climate statistic. It physically restructured the food web off the west coast for 2 straight years. It fueled one of the largest harmful algal blooms ever recorded on the Pacific coast, producing a neurotoxin that shut down the Dungeness crab fishery, one of the most valuable fisheries in the country, for months. Sea lions and other marine mammals, stranded on beaches by the hundreds, starving because the fish and squid they depend on had moved or collapsed. Whales, forced to feed closer to shore in search of prey, became entangled in fishing gear at rates far above normal. None of that stayed in the ocean. The economic losses from the fishery closures alone ran into the tens of millions of dollars for coastal communities that depend on that catch every winter. That is what a marine heat wave actually costs when it's left to run its course, and NOAA's own scientists are now watching a heat wave that, in raw size, rivals it. Here is where the evaporation story turns from an ocean problem into a story about what happens on land. Because a warmer ocean surface doesn't just sit there being warm. It reaches out and touches places thousands of miles away. A study published this January in Nature Communications measured this connection directly, using 2 decades of observational data across coastal regions worldwide. The researchers found that the temperature, the gradient at the edge of a marine heat wave, intensifies surface winds and drives moisture upward off the warm patch, and that this process measurably increases extreme rainfall on the coastline downwind of it. The numbers are not marginal. Across the regions they studied, somewhere between 5 and 25% of the most extreme rainfall days on land, the top 1% of wet days, occurred downwind of a nearby marine heat wave. And where that connection shows up, the rainfall isn't a little heavier. It runs 20 to 30% higher than it would without the ocean anomaly. An extra 4 to 8 millimeters of rain per day, peaking about 1 day after the heat wave's signature intensifies. This is not a one-off finding from a single ocean basin. When scientists went back and reconstructed the extreme North Atlantic marine heat wave of 2023, they connected it directly to the severe storms and flooding rains that hit parts of Europe that same summer, driven by exactly this mechanism: enhanced evaporation and higher atmospheric moisture content moving downwind off water that was far hotter than it should have been. The connection is real. It has already happened. It will happen again. For the United States specifically, the West Coast has its own version of this pipeline, and it has a name: atmospheric rivers. These are narrow, concentrated plumes of water vapor that stretch thousands of miles across the Pacific and can dump the water equivalent of a moderate river directly onto the coast when they make landfall. Some of the most damaging floods in California's history have been driven by atmospheric rivers, and researchers studying the ocean fronts and eddies off the west coast have found that warmer patches of ocean surface directly enhance the moisture transport that feeds these systems, strengthening the rivers before they ever reach shore. So follow the chain all the way through. Record ocean heat, concentrated right now off the California coast, a weakened ability for that ocean to vent the heat back out, because the same high pressure baking the country is holding the wind down, more evaporation as a direct result of both. That evaporated moisture becomes the raw material for the next atmospheric river, or the next extreme rainfall event to make landfall somewhere downwind, arriving sometimes days later, sometimes an ocean basin away, carrying measurably more water than it would have otherwise. The ocean is not just warming, it is actively fueling the next disaster, and nobody's watching that part of the story yet. It's worth being precise about what this is and isn't. This mechanism does not mean every hot day at the beach turns into a flood a week later. The relationship researchers have measured is statistical and probabilistic. A quantified increase in the odds and the intensity of extreme rainfall downwind of a marine heat wave, not a guarantee that any specific storm on any specific date is directly caused by it. The ocean loads the dice. It does not throw them. But right now, the dice are loaded on a scale never before measured in the satellite record. There's a bigger piece of context sitting behind all of this, and it's the reason scientists describe this year's ocean warmth as more than a passing anomaly. About 90% of the extra heat trapped by decades of greenhouse gas emissions has gone into the ocean, not the atmosphere. Oceanographer Brad DeYoung, discussing this year's records with NPR, put it plainly: The ocean has absorbed the overwhelming majority of the planet's excess heat, and events like this are what that stored heat looks like when it surfaces. That stored heat does not release evenly or quietly. De Young pointed out that right now, in the tropical Pacific specifically, water temperatures are running around 6 degrees above normal, a number large enough to ripple through global weather patterns for months rather than days. That is the fuel behind the Super El Niño the World Meteorological Organization says is now strengthening, an event that redistributes rainfall and drought across entire continents as it unfolds through the back half of this year. So where does that leave the heat dome sitting over the country right now? It is not an isolated weather event that happens to be occurring at the same time as record ocean heat. It is one expression of a warmer, wetter, more energetic ocean atmosphere system sitting directly on top of a marine heat wave it is actively helping to intensify, off a coastline that has already seen what an event like this can do to a fishery, a food